Lighting, and I welcome you to this webinar. I'm delighted that Irene Mazzei has joined us and will present EPD or Go Home. The webinar is being recorded and a link to the full recording will be sent to you via email. You can also find all the SLL webinars on the knowledge and resource page of the SLL website. Head to Lighting on Demand, Webinars and Past Presentations. Click that and you will find a very handy tool to help you search and refine all of those presentations. During the presentation, please feel free to ask any questions using the chat function. We will put Irene's contact details in the chat, and Irene invites you to get in touch with her if you would like to know more about this topic, and she can also share the presentation slides with you. Finally, I will introduce our speaker. Irene is Sustainability Lead at Stoane Lighting, and she's been working in the lighting industry for the past 3 years, starting with an innovative collaboration between Edinburgh Napier University and Stoane Lighting on the topic of life cycle assessment in lighting. Before that, Irene received her PhD in chemistry after completing her BSc and MSc in materials science, studying sustainable alternatives to conventional industrial processes. During her work in the lighting industry, she's collaborated directly with manufacturers and the wider lighting community, assessing the impacts of products and processes using LCA and other methodologies. In 2023, she was the technical lead in the working group focused on the creation of a lighting dedicated version of TM65, the embodied carbon assessment methodology, TM65.2, and among other things, she is now leading knowledge sharing initiatives and is directly involved in projects looking at improving the harmonisation of LCA practices in the lighting industry. Irene, over to you.
Thank you, Brendan, for this nice introduction. And so welcome everybody to this webinar today. So I'm going to be talking about rationalizing EPDs and environmental assessment for lighting. And, we'll try to answer the question if we can actually say EPD or go home. So before we start with the presentation today, and really dive into this topic, I would like to briefly present a scheme where I've summarized the landscape of EPD uses and users that I've seen so far in my experience in the lighting industry. So at the moment, we have really a lot of companies looking at EPDs as a means to tick a requirement box, or maybe even gain more points in building level assessment schemes. So we have maybe a lot of attention on EPDs driven by compliance reasons. However, there are also people and companies trying to look past the EPD itself and into the information that it actually it contains to aid decision making. And this is not an easy task for the reasons that I will present today. And lastly, there are a lot of people, unfortunately, that are still maybe unsure about EPDs and product level assessment schemes and methods in general, would maybe don't fully understand the information they contain and how to practically use them. From an industry perspective instead, EPDs, and environmental information in general are being used as a way to protect company interests. For example, saying, we are good company because we can produce EPDs. However, if on the one hand, this type of perspective and, kind of compliance may drive the production of EPDs, on the other hand, it might stray even further from what their intended use should be, which is informing specification decisions to aim for low impact products and, most importantly, monitoring and reducing impacts that manufacturers can do at the product level when they make products, and designers or specifiers at a project level when they then specify those products. So this is really where we should be focusing our attention. So for this presentation and to address EPDs and their use in the lighting industry, and to try and understand how we can do better, I've put together a summary of information to, as I said, try and rationalize these topics together today. So first of all, I'll go through the meaning and the process of creating an EPD, and then we'll look at what the content of these documents is, and what type of information we can find in them. Then we'll move onto the challenges associated with the production and use of EPDs in the industry, from which the question arises of should they be mandatory documents attached to products at this stage. And then we'll conclude with an outlook of recent developments, which may shed some light on what the future looks like on the topic of environmental assessment for lighting products. So what is an EPD and how do we create one? So to refresh our memory, EPD stands for Environmental Product Declaration, and it is a standardized way of reporting life cycle assessment results. It can be applied to products and is recognized worldwide as a reporting tool. So an EPD is a rigorous, standardized, and third-party verified document, which is published by an independent publisher, which is called program operator. But really, it's through lifecycle assessment, or LCA, that we create EPDs. So the LCA is the compilation and evaluation of inputs and outputs of a product system, and the quantification of their relative environmental impacts throughout the life cycle. So the scope of an LCA can vary based on which life cycle stages we consider in the assessment. For example, if we only assess the material extraction and manufacturing of, to make a product, we have a cradle to gate scope. Whilst if we also consider, shipping, assembly, use, and end of life, we have a cradle to grave scope. The cradle to grave scope is what I will be referring throughout my presentation, which is also the scope that you most commonly find in lighting EPDs as well. So what is the process behind the creation of an EPD through LCA? So we start from a company, a manufacturer, which is willing to start this process and commissions an LCA study on a product. So the study is conducted by an LCA practitioner, which can be internal or external to the company. So we have here the first exchange of data and information between the company and the LCA practitioner to collect all the necessary information to carry out the LCA on the product. So for example, a manufacturer will need to collect specific data of the production process for a specific product. For example, the energy involved in the manufacturing operations, or a detailed bill of material. So it is an in-depth communication of data on a product. And this can be more or less time consuming based on different factors, if there is more information required, or if the LCA practitioner is internal or external to the company. That might be also a factor to consider. Then we have the EPD publisher or EPD program operator, which is a crucial part in the process because program operators provide product category rules that the LCA needs to comply to be published as EPD by that specific program operator. Therefore, the LCA practitioner will need to specifically follow those rules to carry out the LCA. And after the LCA is concluded, it is sent to an external independent verifier, which will review the results and the reports. The verifier will then provide feedback, and it may also request changes if they believe that the reports don't comply with the rules. But once the verifier is satisfied with the reports, they will issue an approval statement to the program operator, and then the EPD can be published. So as you can see, it is a complex and time-consuming process. And in the previous slide, I mentioned product category rules, but these are not the only rules that need to be followed to produce LCA results. In fact, the more we want to assess a specific product, for example, a luminaire, the more rules we need to follow to ensure consistency. The LCA practice itself, it's regulated obviously by standards. However, it is not enough to regulate LCA apply to any single specific product. This is why we need more specific rules. So the first most generic standard to apply to LCA is the ISO 14014, 14044 series. Then if the LCA is to become an EPD, the rules to follow are in ISO 14025. And these are the rules for the creation of type 3 environmental communications, which is a long name of that means EPD. Then we can start looking at the first stage of specific products. For example, if the LCA is to be done on construction products, we have EN 15824 as a standard, or for electronic products, we have EN 50693. So it's the first stage of filtering products. And then we look at product category rules. So usually program operators can have two levels of product category rules. There is a PCR Part A, which is the core PCR of a program operator, and there can be a PCR Part B, which goes into specific products, for example, luminaires. In fact, PCR Part B can also be called product-specific rules, so PSR. And an example of this I've just reported here. These are three sets of product category rules, Part A and Part B, from three different program operators in Europe. These three have a PCR for lighting, or a PSR for lighting, and the one on the right is the latest and let's say most consistent PSR for lighting, which is PSR 14 by PepsiCo Passport, which was recently endorsed by Lighting Europe as the most complete PSR for lighting. And in the rest of the presentation, I'll be referring to this one, so PSR 14, a few times. So, yeah. So after defining what the rules are to produce these documents, let's now have a look at the information that they contain. And the first page of an EPD, it's really very generic, presents information on the product, which is the subject of the EPD, which is the so-called reference product. And this means the inputs and the outputs used for the calculation of the LCA results refer to this specific product. However, an EPD can also contain information on a family of products if these are similar enough to the reference product and meet all the criteria outlined in the product category rules used for the EPD. The rules and the program are also reported on the first page, and it's extremely important to report them straight away, because the readers so they can immediately know how the EPD was made, what were the rules that were followed to carry out the LCA, and this is crucial for comparison purposes, as we will see in the next slides. So important concepts that we can find in EPDs, which can also support comparison exercises, are the concepts of declared unit, functional unit, and reference flow. So the declared unit describes the function fulfilled by one unit of reference product. So, the luminaire that is the subject of the EPD in this example can, for example, provide 1331 lumens during a reference lifetime of 25 years. And these 25 years are also expressed in hours. And in this case, we have 100,000 hours, and I will explain in a second how that works. But it is important to express the lifetime also in hours. The functional unit is a concept instead introduced for lighting products by the product-specific rules for luminaires that I've mentioned earlier, so PSR 14. And it's a very important concept and really a milestone for luminaire EPDs, because the functional unit describes the function fulfilled by a standard quantity of product. And this is set for luminaires at 1,000 lumens over 35,000 hours. And by having a standard functional unit, we can report impacts of products as if they were fulfilling the same function. If you think about it, it's like reporting impacts per square meter instead of per single floor tile, for example. So, and that really helps with comparison. So it's very important that we have one defined for luminaires. And how do we convert impacts calculated at the declared unit level into impacts at the functional unit level? We use the so-called reference flow. And yeah, this describes the quantity of reference products or declared units that are needed to fulfill the functional unit. So in the case of luminaire products, we calculate this by dividing the functional units luminous flux and lifetime by the declared units luminous output and lifetime. So here we have a graphical representation of the concept of functional units. For example, we have our definition of the functional unit here, and then two products. Product A, which has a declared unit of 500 lumens, 50,000 hours, and product B that can have 2,000 lumens and 20,000 hours. And the numbers that you can see there are the reference flow. So based on the output of the lumens and the lifetime, we can calculate that we will need 1.4 product A to fulfill the functional unit and 0.9 product B to fulfill the functional unit. So this is how we use the reference flow. So I have mentioned that in the declared units of a luminaire, we need to have the lifetime obviously expressed in hours, because this is the way that we can use to convert impacts between the declared and the functional unit level. However, for consistency with other product EPDs, we should also report the lifetime in years. And how do we do this? So for example, if we take a product that has a declared lifetime of 100,000 hours, and this is declared by the manufacturer based on the characteristics of the product. The PSR 14, the product-specific rules that I've mentioned, introduces a way to convert the declared lifetime from hours into years by introducing the concept of default use scenarios. So as you very well know, the use of a luminaire is very specific. It depends on the project, installation, or building that the product will be finally installed in. And this means that for a manufacturer, it's nearly impossible to predict where a product is going to be installed every time that they make a product. So in an attempt to bring some consistency and harmonization in the way that this is, the lifetime of luminaires is declared in EPDs, specific types of building or the default types of buildings have been introduced with estimated annual operating hours. So as one luminaire could be installed, for example, in different places, the procedure to follow is to list all the possible building types and then selecting the longest annual operating hours, which obviously correspond to the shortest lifetime in years. And if you want, this is a worst case scenario type of approach, but it was, as I was saying, introduced to kind of include some consistency in how this is declared for lighting EPDs. So let's now have a closer look at the environmental impact results that we can find in EPDs. So according to obviously the product category rules that we use, we have to report a list of impact indicators. In this slide that you can see here, I've reported environmental indicators with relative abbreviations and their units. So these ones are the indicators that are compliant with requirements in EN 15804, but other rules might mandate other indicators or different ones, or some are mandatory, some are not. So it really depends on the rules. The first indicator that you see there is the global warming potential total, which is the sum of the other global warming potential indicators reported there. And that is perhaps the most commonly addressed impact indicator, because when we refer to carbon emissions, we're talking about the global warming potential indicator. The other indicators, however, are equally important. And it should really be good practice to be familiar with them, to recognize them, know what they mean. Because, for example, you could have, I don't know, an EPD of a product that has been advertised as optimized to have low carbon, but that might be, at the expenses of other indicators where the impact has instead increased. So we should be able to spot that. And to understand that the other indicators are also equally important. So, for example, one that I could mention now is the abiotic depletion potential of elements, which refers to, the materials we dig out of the Earth's crust, and products containing recycled materials with potentially have lower abiotic depletion potential than a product containing the same material that was then coming from virgin sources. So it is important to understand what they mean. And if you want to know more about the topic of environmental indicators used in LCA and connected to lighting products, you can have a look at the link there to the ARC magazine, where I've discussed this concept in a Green Light Alliance dedicated column in ARC magazine. In addition to the environmental indicators, we also have indicators that describing the use of resources, waste, and outputs for products. Here we can find information, for example, on how much renewable or non-renewable energy was used for and by the product, for example. And this is where also we can see the differences in, if there was a product manufactured in China or a product manufactured in Scotland, for example, because obviously Scotland has a much higher proportion of renewable energy generation than China. So that would be reflected here as well. And this is also why we need to be careful when we want to apply EPD data to a specific project, for example, because EPDs are usually valid or applicable in a specific region or in specific regions, depending on how many use scenarios were included in the EPD, which also dictate the type of electricity mix that was used to model the use stage of the product. So if the use stage of an EPD of a product was modeled for Europe, it will not accurately reflect the impacts of the use in Dubai, for example. So that's another thing that we need to keep in mind. So in addition to the environmental, to the impact indicator, we also have the impact split into life cycle stages for products. So we have here a list of the different life cycle stages that we can have. So we have the A module, which is A1 material extraction, A2 transfer to factory, A3 manufacturing, and these three are usually referred to as the production stages. Then we have transport to site, to the customer as A4, and installation as A5. And then we have module B, which is the use kind of module. And here we only report B2 and B6 because these were, considered as the only relevant life cycle stages for luminaires. So we have B2 as maintenance and B6 obviously as energy in use. And then we have module C, which is the end of life, in which we have from C2 to C4 as waste transport, treatment, and disposal. And then some program operators may also require to report a life cycle stage that goes beyond the end of life, which is commonly indicated with stage D or module D. And this is where the benefits and loads due to the use of recycled materials are recorded. For the sake of time today, I don't think I have time to refer too much to stage D, but I wanted to mention it as this is something that is usually reported in EPDs. So this is how the results are shown on an EPD, and here I've only reported the environmental indicators. So we see on the left the list of the impact indicators, and on the top we have the life cycle stages. So we have also the impacts grouped together, for example, in a total column, and also in a production column, as I was mentioning, from A1 to A3. And in a use column that in this case only includes B2 and B6, as I was mentioning for luminaires. So this is obviously a bit overwhelming at first because it's a table of numbers, but obviously if you're familiar with the meaning behind the indicators and you know what you're looking for, the information is all there. This is a very comprehensive package of information. For example, if you want to know the embodied carbon of a luminaire, and embodied carbon global warming potential. If we go in the total row, this is for the entire life cycle of the product. But if I want the embodied carbon, I have to take the total and remove the use stage, so B6. And that will be my embodied carbon. Or if I want to know the operational carbon, I only have to look at B6. So as I was saying, yeah, the information is all there. We just need to know what we're looking for. And also this table reported here, it was, for example, for the declared unit of a product, but there will be an equivalent table that reports results at functional unit level as well. So as I was mentioning earlier, an EPD can contain information related to a product family. And this is also an approach introduced in PSR 14. Here it's called a homogeneous environmental family. And it is defined as a group of products that share the same materials, the same production processes, the same packaging, the same use, and may differ maybe for material quantity, but not type. So for example, we can consider a product that can mount to different LED sizes, that can produce different color temperatures, CRI, beam angles. In this way, the EPD with one reference product can cover a multitude of product variations. So if we take, for example, the variation of a reference product with a different optic, so we go from a very narrow optic, for example, to a wider optic, the affected parameter will be a different beam angle, therefore a different optical efficiency. So we can expect a different lumen output. And since every other characteristic is the same, with the exception of the lumen output, the life cycle stage that will be affected by this is the use stage. So how much light the product will produce during its use. And so we can also say that the impact of the two products will be proportional to this variation through what we can call an extrapolation coefficient that we can find by dividing the lighting output of the reference product by the lighting output of the product variation. So the concept of extrapolation coefficient is quite useful because using the extrapolation coefficient, we can define, based on the different properties of every product in the homogeneous family, we can calculate the impacts associated with that specific product variation starting from the reference product. So yeah, if we talk about lumen output or energy required to operate the product, the impact changes will only be reflected in stage B6, so in the use stage. If we talk about material changes, for example, a product that has a little bit more material than another, we see changes in the material extraction stage, maybe so. And that is all specified in the EPD, obviously. The extrapolation coefficients are generally reported in a dedicated table, which has a dedicated functional unit table and a dedicated declared unit table, where there is the specific product variation and the associated coefficient that we can use to convert the impacts. So as I was illustrating in the previous slides, and as you can see, because I keep mentioning it, the product category rules and the product specific rules are extremely important to set the boundaries of the LCA that we're carrying out on the product. So yeah, they are extremely important to assess, to define how to assess a product. So it is also why if two EPD were produced following two different sets of rules, two different product category rules, the results reported might not be comparable. And in general, taking a step back, if we refer to this graph, for example, the comparability of EPDs increases if we have alignment on the following aspects. First of all is the LCA scope, because obviously it makes no sense to compare a cradle to gate to a cradle to cradle or a cradle to grave EPD, because the scope is completely different. As I was saying, if the same PCR or PSR is used, if the impact assessment method is the same, so if the model applied for the calculation of the LCA results by the LCA practitioner is the same, otherwise the values that it will return in for the impact indicators will be different. If the data sets used are the same, if they come from the same database, and finally, if we compare products at the functional unit level. So if these factors don't align, we're really just comparing apples with bananas, because the results that we find from the LCA are just different. So going back to the product category rules, what we need to make sure that is aligned or is the same in two different sets of product category rules are at least having the same default scenarios, at least the same assumptions behind the calculation of the product, and making sure really that a functional unit is defined. So talking about challenges, so based on the examples that are brought to you today, you can see how complex and and hard to quantify the information contained in EPDs is. Therefore, it is natural that this process comes with some challenges. The first one is that it's really a resource demanding process, which means time, data, and money. So currently there are agreements that are being put in place to create packages between maybe a program operator and an LCA firm or an LCA practitioner, which are supposed to save money and save time to companies. However, this still requires investments to be made, and for smaller companies, this might mean choosing between producing environmental product declarations or actually investing the money into making their production more sustainable in the first place. And this is, just from the point of view of a manufacturer. But we also hear that, when a designer is required to present the data, there might be formats in which they should be presented. So the work also goes into, puts in the data, puts in the information from the EPD into projects. So this is also time and cost for the specification and the design stages. So if we remember the three intended or foreseen uses of EPDs in the industry, we can actually see how the challenges are related to the use we make of these documents. Because if EPDs are a compliance exercise, companies will just buy the best package that they can to publish as many EPDs as they can without caring about the actual results, and these has nothing to do with sustainability. Instead, if the information we invest so much efforts and resources into producing and publishing as EPDs, if we realize that is the actually important bit, and which is the results of the LCA study, then we can focus our attention on that and on the efforts that it takes to produce them and what this information actually means to us. And from a sustainability perspective, for a company to be able to track emissions and to track impacts of products and operations, it doesn't really need an EPD, but only to be able to apply the LCA to these products and processes. And that information that comes from the LCA can also be shared by the company if the claims are truthful, based on scientific evidence, reliable, non-misleading, verifiable. Because there is a standard, there are rules that regulate the sharing of the information in this way, which is ISO 14021 for what's called a type 2 environmental claim or a self-declared environmental claim. So, these are also cheaper and quicker information to produce and to share, and could be turned into EPDs at a later stage, or if a third-party verification of that information is essential. So the point is that if a company is able to apply LCA to their products and to their processes, it is already a really good thing, and that information can also be shared. So really, the point that I was trying to make here is that an EPD is a document listing environmental impacts of products, but an EPD is not a document that defines if a product is environmentally good. And as a consequence, a product with an EPD is not necessarily a sustainable product, and a product without an EPD is not necessarily a product that is bad for the environment, but the values that these reports contain can indicate that. So that is the bit that we should be focusing on. But we also have to remember that information is not necessarily comparable with other EPDs if the same rules and same data is not followed, as I was mentioning earlier. So all these brings us to the question, are EPDs mandatory? Should they be? So EPDs are not currently mandatory for products. However, the regulatory landscape is starting to quickly move towards reporting requirements also for products foreseen in the near future. For example, with all that is going on in Europe with all the sustainability regulations. However, I think there are a few points to consider if we think about EPDs as a mandatory requirement. Because, as we were saying, EPD production is not possible at the same level for every company. Would it be fair to exclude certain companies from the market based on that? If we consider specials, derivatives, and bespoke products, they should have, according to the mandatory requirement, have their own dedicated EPD. And that might be a huge cost for manufacturers. So it might mean that flexibility of specification might be at risk. And maybe also, considering the adding time and cost that the manufacturer will need to consider, that might mean higher sales costs, perhaps. And finally, obviously, declaring environmental impacts should be mandatory, but only if the system is regulated to allow for fair and equal practices. So what does the future look like? I mean, there is evidence that in the lighting industry, we are steadily getting ahead of the environmental assessment topics. I mean, we can see, for example, so many people attending this webinar, or even so many people already producing these documents, producing EPDs, and trying to understand the environmental assessment topic. So there is at least the interest to do so. So that's really good. Companies are also applying industry-led metrics and assessment methods, such as CIM 65 and 66. And this is exactly why these metrics were introduced in the first place, because it was known that the EPD practice is complex, especially for products such as lighting. So these metrics, these methodologies were introduced as a gap bridging kind of solution until the entire industry is ready to produce EPDs consistently and at the same level. Clients are obviously requesting this information. Projects may have carbon budgets or sustainability targets. So it is definitely there is definitely the demand of this. It's at least growing, and work is also ongoing on standardization and harmonization of LCA and EPD practices in lighting and in the wider industry. And I would like to spend a few words on this because. Regarding harmonization, it is important that we keep in mind that benchmarks, comparisons, and all this can only be achieved if the results are produced following the same rules. And there are developments at the global scale, at least on aligning these rules towards the same rules for lighting, which are inspired or followed by PSR 14 that have been mentioned a few times. For example, there are program operators in North America trying to align to these rules, and there is also work from standardization bodies such as the IEC looking at PSR 14 to create a standardized set of rules for lighting. So really good progress, and we'll probably know more in the near future about these initiatives. And an important role is played also by industry associations, which are obviously here to support and share knowledge and resources with members to, try and help members to start their journey into the creation of EPDs and the use of LCA in lighting and environmental assessment in lighting. And I think this is important to say. This is the time where we should try as an industry to align on the concepts, understand the language, understand the meaning of the environmental assessment results until these practices become more regulated and perhaps mandatory. So just a couple of bits before I finish. So for the designer community, I think, as I was mentioning, this is, we should try to work to understand the concepts of EPDs and LCA communications. work to understand comparability issues, and really try and use the information to help decision making, not just see if a company has an EPD and a company doesn't have an EPD, but use the information to help the decision making process, and engage with the manufacturers to ask them what you need to help with the data presentation in what you need for your projects. So after all this, going back to the initial question, is it fair to say EPD or go home? I think not yet, not now, because I mean, sustainability is not just promoted by creating compliance schemes, but mostly by people, making the right choices when manufacturing and designing. And I think before we create compliance rules and make something mandatory, we need to have benchmarks, and we need to have a fair level playing field, and we need the industry to be able to produce the information that we want to make mandatory. So yeah, that was all from me.
Hi, Irina. Wow, you got through some stuff there. Incredible. Amazing. Thank you so much. Very, very important topic, and very well delivered. We have currently, I think we've got 3 questions. One from Jake, and then Chris, and then Michael. Do you want me to read them out, or are you happy to read them?
You can read them if you want, yeah.
Okay. So from Jake, with so many program operators available with their own sets of PCRs and PRSs, it can be difficult to know which operator to use. Is the lighting industry beginning to become standardized or on any one PO? Without standardization, comparison of EPDs seems impossible.
Yeah, that's very true, and it's exactly what I was saying at the end. So yeah, there are standardization and harmonization initiatives, as I was saying. I think it's good to see also from standardization bodies. So I know the IC is working on some rules. So hopefully we will see that program operators, even if they already have a set of PSR or PCR, will need to update those to align with the harmonized rules. So hopefully
Okay.
this is where we're going.
Hopefully. Then from Chris, how can manufacturers manage changes in their supply chain to keep their EPDs up to date? E.g., a supplier of a subcomponent could swap manufacturing of it between several different global bases periodically. Is there some sort of supply chain EPD proposed so that this would get automatically reported?
Yeah, this is a good question. So usually EPDs are, valid for, it might be 5 years. So obviously once a manufacturer has an EPD out, that's valid for 5 years. And I would say it's unlikely that a manufacturer will go, I need to go back to it and change it, because that would mean cost associated to it. So that is a good question. The answer is probably not. The change, if there is a change in the supply chain, that will go in the other in the next EPD of that product.
Okay, thank you. From Michael, are there no specific targets that an EPD should list to show that a luminaire is environmentally acceptable and is a sustainable product? Currently, it just lists the environmental impact of a specific product or family.
Yeah, that would be very helpful, but unfortunately, there aren't benchmarks in the lighting industry, not for the global warming potential, not for carbon emissions, so not even for all the other indicators. So that is really an area where we should try and invest a little bit of research to try and identify, because yeah, it would be great if you could have color coded tables so you can see if your global warming potential is high or low, but we're not there yet.
Okay. All right. Thank you. From Chris, I was wondering about the carbon intensity and the economic productivity of the resource investment in this process. Also, whether it will reduce diversity of products in some parts of the world, but not in others. A Henry George approach that takes in resource depletion would be to tax the use of resources at the mine head, wellhead.
Yeah, so it's sorry, I was just rereading the question. It's the point that I was trying to make, that it's not only about the global warming potential, because if we consider that for example, if we say a sustainable product is a product made of recycled parts, that doesn't necessarily mean that that product has a really low global warming potential, but it might mean that has a low abiotic depletion potential or other indicators. So it's, yeah, as I said, we're not there yet. So this is why it's important to understand what the other indicators also mean.
Okay, thank you. Dave, thank you for your question. Could this topic potentially be included in industry-wide documents such as the ILP PLGO4 guidance on environmental impact assessments, or is this being investigated?
Is that a question for me?
Was it a question for me? I do. If it's for me, then I do not know. Everybody's trying to put forward their own thing on how things could be, encouraging members to be smart in what they do, and the public as well. I don't know of any sort of joined up approach at this moment in time.
Definitely interesting though, yeah.
Okay, we still got a bit of time if you're okay, Irina.
Yeah.
Okay, from Mark, what does you might want to read this one yourself, the +0 hashtag or number -0 figure in the EPD comparison table mean? Is this power of, i.e. add or subtract the number of X zeros?
Is it I think it refers to the it's scientific notation of the numbers. So I'll just put the slide on a second.
Okay.
So give me a moment. Yeah, so I think it refers to this table. And it might be the E to the -3. So this is called scientific notation. So in this case, E plus 0.3 means that you need to move the point to 3 places forward. If it was minus, to 3 places behind. So in this case, this would mean 6,570 because you move 1, 2, 3. So it's that. It's a way to represent big numbers or small numbers.
Thank you. From Mim again, as a designer and specifier, when working on a net zero project, we get asked for EPDs for specified luminaires. But what does this add, I think, on a net zero project when there is no compliance criteria?
This is a very interesting question. So for a net zero project, so if that project calculates, scope 1, 2, and 3, the products that go in it will probably count as scope 3 emissions. So it might mean that they're trying to arrive like some of the carbon emissions. I couldn't find the word carbon there for the scope 3 of the project, which is funny. Yeah. So product EPDs that reports global warming potential, so carbon emissions of products, might help in calculating the scope 3 emissions in a project. This is one reason that I can think of. Or they're just trying to meet some sustainability targets or criteria for that specific project.
Okay, thank you. Rhea, can a product with TM65 assessment be compared to a product with an EPD assessment extracting the declared unit embodied carbon information? I have read that TM65 overestimates the embodied carbon.
Yeah, it does. So no, the short answer is no, because TM65 and EPDs are totally, LCA and TM65 are totally different methodologies. So I wouldn't compare them. What you could compare though is if you have two products and you have a product that has 50% more carbon, so it will be 50% more carbon if you calculate it with TM65 or EPD. So that is the thing that you could compare, but no absolute numbers. You can't. And yeah, TM65 tends to overestimate embodied carbon. I did some research on this, and we published a paper a couple of years ago, or last year, where we compare the LCA and the TM65 of 6 luminaires, and we did observe that the TM65 embodied carbon was overestimating the results in all 6.
Okay. Significantly overestimating?
About between 30 and 60% that I can't remember now, but yeah.
Okay, thank you. Ward, what is the value of an EPD if maybe 80% of the impact comes from the use stage and the electricity impact is so different dependent on the country or data set? This seems very confusing to compare different products today.
Yeah, this is a good point. So there are a few things to say here. So if we consider the rules for LCA, that was the pyramid that I was mentioning at first, the top layers of the pyramid need to comply with the bottom ones. And LCA tells us that we can't ignore emissions if they're part of the life cycle. So it is important and it's necessary that we consider use emissions for luminaires, even if they are an electricity consuming product, so they will be high. So this is why we have to include them if we do a cradle to grave EPD. Yeah, so the electricity impact is different depending on the country or data set. That's true. This is why sometimes program operators want you to include different use scenarios. So for example, you can say that your EPD can be applied in Europe or in the UK, for example. So you use the electricity mixes of both. But yeah, it is impossible to capture all the possible use scenarios, as I was saying. This is where having an EPD and having a specific project, this is where the designer or specifier or whoever is using the data says, okay, now I need to remove the use stage and calculate the use stage based on the information that I have on my project. So it is a bit tricky. Yeah.
Okay, we'll run out of time. I think we've got probably enough time for 2 questions. Christina's asked, referring to an earlier question, was the carbon emissions overestimated from TM65 or TM65.2?
Thank you for the question, Christina. So the carbon, there was in both cases an overestimate in TM65 more than in TM65.2, because in TM65.2 what was done, we tried to kind of reduce the overestimate and reduce the areas where people could try and include data that wasn't really applicable to lighting. So in this way, we included, for example, more material coefficients, so that's people could select a specific material and that overestimate gap could reduce a little bit, and it does, but it's still TM65 is still a conservative methodology, so we always expect to overestimate results with it.
Okay, thank you. Elliot's sound cut out, unfortunately. He's asked if you can define the difference between cradle to cradle and cradle to grave.
Yeah, so cradle to gate. Sorry, what was cradle to grave and cradle to cradle?
I've lost it now. I think that was right. Cradle to cradle and cradle to grave.
Yeah, so cradle to grave is for an EPD that goes from manufacturing through use to end of life. So it's modules A, B, and C. Cradle to cradle instead also considers module D.
Thank you. And the very last question from Chris is a follow-up to his previous question. If manufacturers do not have to update the EPD for 5 years, is there a risk some will game the system e.g., do the EPD based on a first-class product, then cut costs with less good components, like buying organic food and finding it is made in a factory?
I'm afraid I don't know what first class product means.
I think it's getting the EPD and then substituting components with something of a lower quality.
Oh, okay. Okay. Yeah, yeah, yeah.
Or a lower, it could have just been mined fresh out of the
Yeah,
ground instead of actually being, say, um, uh, yeah.
yeah. There is that risk, obviously, because it's up to the company that produces the EPD. Some of that risk is mitigated through maybe the third-party verification. If the verifier is thorough, super, super thorough, and really investigates that. But yeah, it's if it's up to a company, there might be people that do that. But hopefully not.
Okay. And then I think there's only one last question, so we'll get this done if you don't mind. Maria, again, would it be fair to assume that until EPDs are constantly used across manufacturers, TM65.2 information should be prioritized so that we can fairly compare across similar products?
So I think one doesn't exclude the other. So obviously everybody is now able to use TM65.2 because it's a super accessible methodology. I mean TM65 in general, and it can be easily be applied to products, and now also to lighting products more easily. So yes, absolutely. If people started producing data for the industry using that would be great. But at the same time, it doesn't really prevent people from starting the LCA and the EPD journey as well. Actually, it should be hopefully supporting it so that people start asking themselves the questions, and since they start investigating that area of their production, maybe going from TM65 to LCA shouldn't be that traumatic. So yeah, absolutely.
Okay. Many of the attendees are thanking you, Irina, and I thank you as well. Thank you so much for taking your time out, delivering this presentation for everybody. The presentation or a link to the presentation will be sent to everybody that's attended the event in a few days' time. Big thanks to you, Irina. Thanks to the audience taking part, and my colleague Fiona for enabling this webinar. If you would like a certificate of attendance, that's annoying. If you would like a certificate of attendance, please email sll@sibsi.org. Many thanks. Bye-bye.
Thank you for having me. Bye.